Dear colleagues, we would like to present to your attention a scientific research on the topic project-oriented approach to the study of robotics according to the concept of STEM education. The intensive development of robotics and the use of self-regulated production systems inevitably leads to the changes in the labor market and the emergence of new professions and requirements for that. Robotics production requires specialists who can carry out its development, research, maintenance, prepare, control, design, and commission. This leads to an increase of requirements for modern specialists capable of innovation and the solution of non-standard professional tasks based on the development of research competence. The trends in the development of IT technologies lead to the changes in the education system and its methodologies, in particular the introduction of STEM education. Despite the widespread coverage of the problem of introducing STEM education, the issue of developing a methodology for studying technologies for creating robotic system remains relevant. A feature of the educational approaches for study of robotics is the need to conduct in the various fields of knowledge, material science, electrical engineering, microprocessor technology, programming, production technology, Internet of Things technologies, and others. However, training standards and materials on the market are either too expensive or too limited in functionality, training materials or techniques. On the other hand, working with a ready-made robotic complex does not allow to master the technology of development of robotic systems. In the study of the finished complex, the modernization process is ignored. Therefore, one of the ways to teach robotics is to use a project-oriented approach and that provides solutions to these problems with a greater efficiency. The use of project-oriented approach in the study of robotics allows to fully implement the main provisions presented in the concept of the development of STEM education. In our proposed method of using a project-oriented approach in the study of robotics, at the initial stage, a problem is selected and a subgroup of students are formed, who will solve the task. The task is selected from a wide range of practical problems. For example, the development of a robotic arm or a running gear of work or smart home and smart city elements. Students in the process of studying technologies for creating robotic systems independently develop and produce a training stand in accordance with the chosen option for a practical task. Using the developed training stand, students have the opportunity to explore its properties and ways of modernization. The theoretical material is explained on the basis of the implementations of the stage of practical development. The study presents a methodology for teaching robotics using a project-oriented approach. On the example of the task of developing a robotic platform, at the initial stage, the teacher invites students to explore the existing types of selected solutions to the problem, their strengths and weaknesses. For example, the development of a running gear is chosen, which will have mechanisms for turning each individual wheel by 90 degrees and the ability to control the speed and direction of rotation of each wheel. In the process of implementing a project-oriented approach, an important point is to hold a discussion among the students, where they should discuss problematic issues as much as possible. For example, in solving R-applied problems such as questions will be following. Is it necessary to choose which element base to use? What materials for the body to choose? What types of wheel is better to choose in this case? What problems may arise? What characteristics are planned to be included in the design? How will the wheels turn? At the next stage, students learn the basic functions of working with the CAD system to develop drawings of details of the design of the robot. To do this, they are provided with sufficient instruction to be able to make a drawing of the part. Such brief instruction does not allow you to fully master all the functionality of the software project. On the other hand, students are provided with additional educational material in the form of video tutorials, which will allow them to fully master this project on their own. Preference is given to pre-CAD systems and systems that allow you to work on a project in a team, such as Autodesk Fusion 360. In this case, each student develops his own role of several nodes, such as servomounts, batteries, solar panels, motherboards, or sensors. The developed drawings are exported in the STL format, which their subsequent preparation for printed on a 3D printer. This allows to consolidate the knowledge gained in the process of studying design technologies using CAD-system and visualize the process of manufacturing the body and development and design of relevant design documentation. The next stage in the implementation of the project-oriented method is the development of structural electrical circuit diagram with its maximum required functionality. As in the case development case, first there is a discussion of conceptual scheme and the nodes that should be included in it. The component-based power supply microcontroller sensors are selected and their characteristics are discussed. At this stage, the theoretical material is consolidated to understand the principles of connecting the selected microcontrollers, their settings for operation, and port assignment. To test the algorithms of these systems, students are offered to develop a simulation circuit diagram in Tinkercad. This allows you to implement the basic elements of the work and work out their interaction. This approach allows them to visualize the work of key components of the system, their relationships, and prepare students to work with the physical model. This stage also offers an explanation of the theoretical material related to the operation of controllers, pulse width modulation drivers, and servo structure. The student is invited to consider the key components of the system, their physical and software principles of operation, possible design options. At the final stage, the electrical and physical motors are combined in the single stand. Motors, servos are connected. They are calibrated and the functionality of the software algorithms is implemented. This allows you to consolidate and develop skills and abilities acquired at this stage of simulation, as well as physically visualize the work of the system, its movement and reaction to the environment. The developed design and algorithms are further studied by the students in the real circumstances. The shortcomings of designs and algorithms are sought and eliminated, their interrelations are investigated. Students are invited to study their implemented projects, for example, on the subject of motor overload, structural rigidity, cross-country ability, reaction speed. After the completion of this stage, the final conclusions are formulated, in which the key role is played by the result achieved by the students and the ways of modernization proposed by them. Since the goals and conclusions of the study are formed together with the students, this allows students to increase their competence in using the methodology of the scientific approach, from setting tasks to analyzing their results and reliability. Thus, the use of a project-oriented approach in the process of studying robotics ensures effective research work of the students, not limited to standard education standards, educational materials, and software. The use of self-developed educational standards allows to systematize information about the object of research conducted on the specific practical tasks and to strengthen the cognitive activity of the student. This approach allows you to significantly raise the self-esteem of the students and increase their motivation to learn. Working on solving problem-oriented complex tasks allows us to consider the task as a collective one, which will create the necessary prerequisites for professional activity, since in real life most types of work takes place in a team. Also, this approach allows the student to find exactly the niche in the project that appeals to them the most: programming, development, structural detail, or the creation of electrical circuit diagrams. Prospects for future research are to improve the methods of teaching robotics based on a project-oriented approach using the potential of interdisciplinary interaction. Thank you for your attention.